Welcome everyone. My name is Stefan Radke, and in this video we'll explain how Qumulo replication works, and we will show how to set up replication between a cluster in AWS and another cluster in Google Cloud. First we will cover some basics about Qumulo replication. Then we will review the AWS and GCP landscape that we are using to implement clusters and establish replication between them. And then we will finally do it and review the AWS and GCP landscape in the console of AWS and GCP. We will then set up a first continuous replication relationship, and after that we will create a snapshot-based replication relationship and explain the differences. And then we will add another replication relationship between an on-premise cluster and the cluster in Google Cloud. And then finally we will wrap up with a short summary. Let's start with some Qumulo replication basics. Replication is being used, for example, for collaboration, where people around the world or many different locations needs to work on the same data set, and the data set must be replicated. It is also being used for backup and disaster recovery. It is being used for migration. It is being used for data relocation and many more use cases. The Qumulo replication can be established at directory level, and if you pick and choose a specific directory from which you want to replicate to another location, everything that is in that directory will be replicated, including subdirectories and files. Only change blocks are being replicated, so that's very fast. We identify, for example, if you have a file that has some changes, we will only replicate those changed blocks. So it's very network friendly and it's very fast. We can configure two modes. We can configure continuous replication or a snapshot policy based replication, and we will see both in a minute. Obviously you can also configure both at the same time. The traffic is encrypted over the wire, so that should be considered secure. It uses port 3712 per default. This can be changed. And one thing that we need to mention is that the target directory is read-only as long as the replication relationship is active. And that's very important because we want to keep and guarantee consistency in the dataset. The replication works in this very same way on all platforms that Qumulo supports. In this video I will show 3 different platforms. Regardless, in every platform that Qumulo supports, that's being cloud and on-premise and different hardware vendors, the replication, as all other functions in Qumulo, are working in the very same way. Here's a typical landscape in which you would deploy Qumulo clusters. On the left hand side, so you see the AWS landscape that I have set up, and on the right hand side you see the Google Cloud setup. I have created a separate secure subnet for the Qumulo cluster. This is not a must. You can also configure it in the same subnet in which your clients are located. That depends on your security configuration and requirements. The deployment of the Qumulo cluster itself, we have shown that in a different video. You just select the proper CloudFormation template and then you set deploy, and then you pick and choose your region, your VPC, your subnet, and then it's being deployed really instantaneously. After we have created the cluster, we will create a share and mount that to a Windows client. On the Google side, we do the same thing. We deploy a cluster that's being deployed through the marketplace. That's being done with a Google deployment template, and same here. It's very quick and easy. We create a share as well. We call the share the same, so the share name is data, and we mount that to a Windows client in the subnet, in a different subnet. Again, here you could decide to do it in the same subnet. Finally, we have to also configure a public IP address for the Qumulo cluster on both sides because we need that for the replication job. Of course, we would configure our firewalls rules accordingly. That means our NACLs in AWS and our firewall rules in Google. Finally, we will create the replication relationship and show how it works. So why don't we get started? Let's start by reviewing the AWS console. As you can see here, I have set up a Qumulo cluster through a CloudFormation template that took just 2 minutes. And here is another Windows server that I have set up to be able to mount a share that I have created on the Qumulo cluster. Here's my Google Cloud console, and I'm just showing you I have deployed a cluster here. That's my 4-node Qumulo cluster, and also in that same VPC I have a Windows server running. So same thing on both sides. Now let's go to my AWS instance first. This is the source of my replication. Here is my AWS cluster, the web UI from Qumulo. Here is the dashboard that gives you a brief overview of the cluster and what's going on. But we will focus on replication. First of all, I'm showing you the SMB share that I have created, and I named it AWS Data. That's it. You can briefly watch it. Here's the directory. Here's the share name. The share name is called Data. Here's the description. And here I can give some share permissions. I have mounted this share to my Windows system, which I'm logged into right now. And you can see this is mounted as Drive Q. So I can even move data into it. You can see that. I can write to it, delete data, and so forth. You can see I'm in my Windows instances in AWS. That's the small icon above here. And I'm now switching to my Windows instance in Google. Here is my Windows instance in Google. I'm also connecting to my local cluster in the same VPC. Here's the cluster. Here's again the dashboard. And I'm showing you another SMB share which I've created on this cluster. This is called GCP Data. That's the directory, and the share is also called Data. I've just named the file system path on both sides differently so that you can distinguish it. Obviously, we can also use the same name on both sides. I have also mounted the share on this side here. So I've also mounted it as drive letter Q. So now let's move ahead and create the replication itself, or the replication relationship. I'm going to my AWS cluster. So let's go to the replication page, clicking on replication, create relationship. So now here it's pretty much self-explaining. I have to enter the path that I want to replicate. AWS data. And the target directory on the other side I have named GCP data. Here is the target IP address, and remember we have set up a public IP address on both sides for replication, and here is my target address on the GCP side. So going back into the console, pasting that address. Here I can pick and choose the port number. I leave it as default. Obviously, I have created a firewall rule on the GCP side to allow ingest traffic on this pod. And if you want to do replication in both directions, you obviously have to create that firewall rule on both ends. Here I'm able to pick and choose the replication mode. And for now, I can only create continuous replication. That means as soon as changes are detected, they will be replicated. I have also a chance to do snapshot-based replication, which I'm going to show later. Save relationship. Here you can see I have now established the relationship from my local cluster, AWS data, to my remote cluster, GCP data. And now I need to go on my other cluster to be able to accept the request for the replication relationship. So I'm jumping to my GCP cluster, and you can already see in the UI here that it says we have discovered one replication relationship authorization request, and I can click on details. Here you go. That's the request that I have from the other side. Obviously, I would say authorize. And that's basically already it. The replication relationship is now established, and since I have selected continuous replication, I would have instantaneous replication once changes have been detected. So I'm going back to my AWS cluster. Here's my directory. That's empty right now. And I can just put some files in. And when we go back to the target side, we will see that in a moment the data will arrive on this side as well. And here we go. I can do the same if I remove data on the other side. These changes, or this change, in this case it's only one change, will also be replicated to the other side, which is a delete. And here you go. The deletion has also been propagated. I want to mention that the target side is read-only in this moment. This is because we need to guarantee consistency on both sides. So I can't write stuff to this directory. You need permission to perform these actions. Well, I don't have, because right now the replication relationship is active. So if I want to make this writable, for example, in case of a disaster or in case of a planned failover, I need to stop the replication. I can do that here. Delete the relationship. Yes, this will delete the relationship between my AWS cluster and my GCP cluster. Now it's deleted, and you will see I can now also write data to that directory. Another thing that I want to quickly show is that we can associate our replication relationship to a snapshot policy. In that case, the replication will not be performed instantaneously rather than based on the policy of the snapshot. So let's have a quick look. I go to cluster and say snapshot policy. I'm creating a policy name that says data every hour. So my directory will be AWS/data. Here we go. And then I can select my schedule. I could say every hour, and then I say every 60 minutes. I don't limit the time window. I could limit this to off-peak hours. I will do that every day. And here it's interesting, I can now set when the snapshots will be deleted. Automatically delete all the snapshots taken after 3 days. Save. Here's my snapshot policy. Now this is just local. That means every 60 minutes the AWS data directory would be snapshotted. And after 3 days the snapshots will automatically be removed. Now let's go ahead and create our replication relationship again. Here is my source directory, AWS and data. The target directory was GCP data. My target IP address. And now you can see, since I have created a snapshot policy, I can choose between continuous replication or snapshot policy replication, or even both. So for now, let's do snapshot policy replication. I can pick and choose the replication policy. Since I have only created one, here's the one. Now, this is interesting. I can set different deletion policies on my target side, which absolutely makes sense, right? So on my local cluster, I've said delete the data after 3 days. And on my target side, I could say delete them after 30 days. The target cluster, if it's being used for replication and backups and so forth, typically has more space. So it's absolutely valid to say keep the snapshots longer on the backup side. Again, I'm not adding any blackout windows here. I'm just saying save relationship. Now I need to go to my target side and accept the replication request and click on authorize. I'm informed now that all my data that I've written to my target directory, GCP data, will be deleted, which is obvious because I want to have a replication of my source directory to the target side. And as you know, I've written some data before here, right, from the local side. Like I can create a file, and I can say yes, confirm, and then you will see that this data will be removed as soon as the replication kicks off. Here we go, right? So the first snapshot has been taken immediately after the replication relationship has been established, and as a result, the data that did not exist on the source side will be removed on the target side as well. Okay, that was it. So we have seen two different things: continuous replication and snapshot-based replication with different retention times on both sides. And obviously I could do both things at the same time as well. Let's go one step further and also establish another replication relationship from an on-premise Qumulo cluster to our cluster in GCP. So here's my on-premise cluster. It's a completely different one that resides in our data center. You can see there is a couple of shares and exports created, so we're using that cluster from our internal team. I have created a home data directory where my data resides, and I want to create a relationship to the Google cluster, as I said. So let's go ahead. Cluster, replication, create relationship. My source directory path is home data, as I just said. My target directory will be home data as well. My target IP address is still the same, my Google cluster. I will leave the default port number since I have set up my firewall rules for it, and I click save. You can see this cluster is already also replicating to somewhere else, but here's my relationship that I established. Now I need to go to the target cluster, and here you see already, here's my authorization request from the on-premise cluster, and I can say authorize, and here we go. That's it, as simple as that. And now on my Google cluster I have two incoming replications, one from my AWS cluster and another one from my on-premise cluster. Finally, I want to mention that you can create more complex data replication scenarios. In this setup, we see the AWS cluster, for example, has a 1-to-n relation since it replicates into the Google and the on-premise cluster. The cluster in Google, though, has an n-to-1 relation since two other clusters replicate data to it. And all clusters are source and destination clusters for different directories at the same time. Let's quickly summarize. Qumulo is a software-defined solution that runs in major cloud environments as well as different on-premise platforms. Data replication can be established within a single cloud, between different cloud environments, between an on-premise and a cloud environment, and you can configure 1 to n or n to 1 replication scenarios. That is all possible. The advantages are obvious: limitless data mobility, platform agnostic, same look and feel everywhere, ease of use. You don't really need a training to configure the things that we have seen in the video. Implementation of Qumulo is automated by Qumulo provided CloudFormation templates and deployment templates, so even the deployment of a Qumulo cluster itself takes just a couple of minutes and is very easy. Here are some useful resources to read and watch, some videos and some documentations. All links will be provided in the description section of this video. That was it for today. Thank you very much for watching. If you liked the video, feel free to subscribe the channel, and we will see you next time.